Okay, good morning. Welcome to
SuperMath number 9.
SuperMath9. This is one of the example problems from Art Problem Solving's algebra book in the parallel lines section. Oh, sorry, geometry book.
Yeah.
In the parallel lines section, and this is actually kind of a famous challenge problem about parallel lines. Okay, so it says in the diagram, line L is parallel to line M, and the angles are given. So we have this interesting thing where you go from A to B, and then from B to C. You start out here with a 130-degree angle. What does this symbol mean here?
That's a right angle.
That's a right angle. So what does that mean? 90
degrees.
Okay. And we're asked to find the measure of this angle here, which I'm called x. Okay.
All right.
So this is actually a good challenge problem. What do you think you want to do here?
Well, I'm going to extend these lines a little bit. I'm just draw this third line.
Okay.
To help me.
I was going to say that's you're not really extending an existing line there. Okay.
And then these lines.
Okay. Great.
So this line here, this angle is 50.
All right, that angle's 50. Good job. Why is that, by the way?
Well, because
what rule are you using?
It's supplementary to this one, which means that these two add up to be 180.
Okay, so those angles are on a straight line, so they add up to be 180.
And this line is supposed to be parallel to these two. Okay.
Ooh, interesting question. Why can you draw a line through this point that's parallel to this line?
Well, this is like the point that's sort of halfway between these two.
Well, it didn't say that.
Or
it didn't say where it was.
You just have to draw it completely straight.
Yeah, why can you do that though? Why if I give you a point, can you draw a line parallel to another line?
Well, all you need is a point. You can like move that line up.
Okay. From looking at it, it looks like you can do it. But why is there a math reason why you can do it?
Well, you're not really changing the problem.
No, you're not. This is called the parallel postulate. Have you heard that before?
Yeah.
Where?
When we were talking about parallel lines.
Okay. So one of the Euclid's postulates is if you have a point, you can draw a line parallel to another line through it.
But
exactly.
There's no proof.
Right. It's just one of the things we have to accept. So you're using that parallel postulate idea here. So I just wanted to point that out.
So this means that this is 50 here. Because of the parallel line rule. Okay. Good. This is 50 from our opposites.
All right.
And this here, this whole thing is 130.
Okay. Good.
And we need to find angle x.
Yeah, we're trying to find angle x.
So we can still use this line.
All right.
So this is 50. That's 50. And this is 130.
All right.
So now this angle, this whole thing, well, if we can find what this angle is, then we have it.
Yeah. Interesting.
So this here, that's 130.
Okay, good. This big angle here is 130. Nice.
So this angle is 90.
That
this is 50, so this is 40.
All right.
So it means this is 90.
That's 90. How else could you have seen that this angle here was 90?
Well, you have the opposite angle, maybe.
See, it's on a straight line right here, and this angle's 90.
So that angle has to be 90.
That angle's 90. It's tricky to see those straight. Okay, but now you have a 50-degree angle and a 90-degree angle.
So that adds up to be 140. So x is 40.
Why?
Because angles in a triangle sum up to be 180.
Because angles in a triangle add up to be 180. Okay. Very good. Very good job with that. you use the parallel postulate. Drawing in that line, that was a good thing to do. Drawing in this line was a good thing to do. The other way you could have seen this angle was 40, was from this parallel line you have this is a 40-degree angle.
So
you see that?
It means this is a 40-degree
Draw it.
angle.
Means that's a 40-degree angle. And which means that's a 40-degree angle. Okay, very good. Good working through that. That's those geometry problems can be pretty challenging.